Okay, so after seeing that first video, hoping you're asking yourself, okay, that was pretty easy. How do I get to that form? Because that was so easy. So that's what we're going to look at to start with, and then we're going to look at some applications of this. So to start with, how do I get to that form? Well, the way we get to that form is by completing the square. So I start out, I simply look at this equation. Okay, what I'm going to do, same process for completing the square. I'm going to move the 7 over. So I'd have an x squared minus 6 equals a negative 7. Now the question is, what do I add on to complete the square? So if you remember from last week, we are simply taking half of the b term, or half of this negative 6, and we're squaring it. So half of negative 6 is a negative 3. Squaring it is a 9. So I'm going to add on 9 to both sides. Okay? So what did I just create? I created this. I've got an x minus a 3 squared equals a 2. Now, from there, I simply move the 2 back to the other side, and I rewrite it back into function form. So my final answer, so that I have it in this f of x is equal to a times x minus h squared plus k form, or some people refer to it as vertex form, is this, x minus 3 quantity squared minus a2. And then from that, you could again easily graph it. Okay, and that's what we'll look at in a little bit. Okay, so the next one, what happens if it's not such an easy one? Well, what do I mean by that? Like something that's not an even in the middle. The process remains the same. So I got an x squared plus a 5x. I'm going to move the 8 over right away, so that would be a positive 8. Okay. The next step, again, is half of the middle, or half of that 5 squared. So half of 5 is 2.5. 2.5 squared is 6.25. So as odd as it may seem, we're going to add on 6.25. Okay, so I just formed a perfect square. That perfect square would be an x plus 2.5. Again, where does the 2.5 come from? Two different places. You can think of it as half of this b term or the square root of 6.25. So I got an x plus 2.5 squared equals 14.25. And again, the final step, move things back across, and you write it in this function form, x plus 2.5 squared minus 14.25. And if we thought about shifts, we would know that this plus 2.5 would be shifting it left 2.5. This minus 14.25 would be shifting it down 14.25. Okay, so now we stepped it up a bit. We didn't look at any of these last week. I said you didn't have to do them, but now is the time where we need to look at them. So if I were to look at this one, again, I would start out with this form, 2x squared minus 12x minus 14 equals 0. Process starts the same. I move the 14 over. So now I've got a 2x squared minus 12x equals 14. And now what I want to do on this side, the left side, I want to factor out this 2. So I end up with an x squared. So if I factor out a 2, I'd have a 2 times an x squared minus 6x. Okay, so the process now, very similar to what we did before. We're looking for what gets added on here to complete this square. So if I got a minus 6, half of a minus 6 is a negative 3, squared is a 9. So I'm going to add on 9. However, I'm not going to add 9 to the other side. What I instead have to add is what the product of the 2 and the 9 would be, because that's truly what we're doing. It's still 2 times that 9. So that would be an 18 is what I'm going to add on. So I would have 2 quantity x minus the 3 squared equals 32. If I rewrite it now so that I get it back into function form, it would be 2 quantity x minus 3 squared plus 30, excuse me, not plus, but minus 32. Okay, Uh, Next one, similar, except now we have to think about how else could I have written this? Uh, this f of x could have also been written, instead of dividing by 2, you could think of it as multiplying by a half x squared. Half x squared is the same thing as x squared divided by 2. So process starts the same. I've got 1 half x squared minus 4x. I move the 3 across. So that becomes a positive 3. And now I'm going to factor out a 1 half. If I factor out a 1 half, I'm going to have an x squared. In this case, it's going to be minus an 8x. Over here, I still have a 3. So we take half of that middle term, which is 8, or excuse me, half of the middle term is 4. 4 squared is 16. So what I'm going to add on to both sides is a 16. Well, the one side is 16, but I forgot that I have to multiply the 1 half times 16. So I'd be adding on an 8. Okay, so this now becomes 1 half quantity x minus a 4 squared equals 11. So if I get it back into function form, I'd have f of x is equal to 1 half and x minus a 4 squared minus 11. Okay, next thing, if I have to graph this now, again, we're going to start by getting this x squared minus 4x plus 3 into that vertex form, or completed the square form. So I've got an x squared minus 4x. I'm going to move that 3 across right away. It's going to be minus 3 on the other side. Okay, what am I going to add on? Well, half of a negative 4 is negative 2 squared is a 4. So I add on 4 to both sides. So I've got now an x minus a 2 squared equals a 1. If I move it back across, back into function form, this thing right here would be x, or f of x is equal to an x minus a 2 squared minus 1. From the previous video, we should now know that that's going to be a shift right 2, down 1. Right 2, down 1. There's my vertex. My axis of symmetry would be here. I know that the a value is a 1. Means it's going to open up. It's going to have the standard pattern. Up 1 over 1. Up 3 over 1. Up 5 over 1. Okay, I can mirror them across. And there's my nice, neat parabola. My vertex would be 2, negative 1. My axis of symmetry would be x equals a 2. In this case, I would have a min of a negative 1 when x equals a 2. Okay, hopefully that one made sense. Let's look at another one. If I now have a negative 1/3, or a negative x squared divided by 3, which can be rewritten as a negative 1/3 x squared plus 2x. If I move the 1 across, it'd be a negative 1. And again, I'm going to factor out a negative 1/3. If I factor out that negative 1/3, this would become a 6x. So what do I have to add on? Well, half of 6 is 3. 3 squared is 9. So I'm going to add 9 here, but a negative 1/3 times 9 would be a negative 3. So I'm really going to subtract 3 from the other side. So what do I get? I now have a negative 1/3 x plus a 3 squared equals a negative 4. If I rewrite that now into my function form, I would have a negative 1/3 x quantity, oh, not x, sorry, getting ahead of myself. Quantity x plus a 3 squared plus a 4 when I move it back across. So the plus 3 would tell me I'm going to shift it left 3. The plus 4 shifts it up 4. So I got a vertex there of a negative 3, 4. My axis of symmetry would be x equals a negative 3. If I draw my axis of symmetry, and now I have to think about what my pattern is going to be. I'm taking 1/3 times a 1, 1/3 times a 3, 1/3 times 8, 5. And again, it might not be that pretty, but we'll be able to work with it. I got a 1/3, I got a 1, I got a 1 and 2/3. So estimation is going to be all right. I go up a third over a 1, up a third over a 1 on the other side if you want. From there I go up 1 over 1. Okay, and then I go up 1 and 2/3 and over 1. Okay, so I get this pattern coming about like so. So I get something that looks like that. In this case, again, I got a minimum. Oh, 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 boy, I messed up. These should all be negatives, shouldn't they? Somebody's saying to themselves right now, Mr. Velarde, you screwed up. And you're right. So these are all negatives. So I go down 1/3 over 1. I go down 1 and 2/3 over 1. Down. Oh, messed up again. Okay, down a third over 1. Down 1 over 1. Down 1 and 2/3 over 1. So I'm going to end up with this shape here. Okay. In this case, I have a max, and that max is a positive 4 when x equals a negative 3. Okay. Some other questions I might be asking you might be something like this. So find the vertex, determine whether there is a min or max, and the value, find the range, find the intervals in which it's increasing or decreasing. So my first step would be to get this into this form. So I have to complete the square. So I've got x squared plus 4x, move the 5 across, it's a positive 5. Half of the 4 is 2, squared is 4, so I add on a 4. So this becomes x plus 2 squared plus a 9. So when I move it back into function form, it becomes an x plus a 2 squared minus a 9. So find the vertex. Hopefully we can see. Shift it left 2, down 9. So it's going to be a negative 2, negative 9. So if I'm thinking of where is it located, negative 2, negative 9, it's here, and it's opening up. It's going to do something like that. So determine whether it's a min or max. Hopefully we can see that that's going to be a minimum. And it's going to be a minimum of negative 9 when x equals negative 2. What's the range? What are the y values? What are the possibilities? Hopefully we can see that the y has to be greater than or equal to a negative 9. Last chapter we looked at intervals of increasing and decreasing. Hopefully we can see that on this side is decreasing. So I would say decreasing from negative infinity to a negative 2. I would say it is increasing on this side. So increasing, excuse my poor penmanship, a negative 2 to a positive infinity. Okay. If you're going to look at one like this, for this one, I'm just going to give you the hint. I'm not going to have time to go through it on this video. So what you're going to want to do, you're going to want to get in the, that vertex form. So factor out the negative 16, do the completing the square, and then from that, you're going to be able to turn your vertex. That vertex will then tell your maximum height and the time at which it reaches its maximum height. Your ordered pair that you find will be this, a TH. So the first value is going to tell you your time. The second value is going to tell you your height. So again, follow through that process of completing the square. From that, you will be able to tell what the vertex is, which will tell you the two answers to that question. Okay, hopefully this all makes sense to you. And I appreciate your patience.